Hey everyone, welcome to the video series on Introduction to Machine Learning with Scikit-Learn and Python programming language. This is chapter 4 part 1, and in this particular chapter we will look into some of the prerequisites which we need to fulfill before we can start our journey with machine learning in Python programming language and with Scikit-Learn. I will highly recommend you to go ahead and look into my chapter 0, 1, 2 and 3 before looking into this particular chapter. It will help you to understand the code I am going to write over here. Okay, so the first prerequisite which we are going to talk about is NumPy. NumPy is also called numeric Python, and if you are working in Python you must have heard about something called NumPy. NumPy is the first step towards your journey on machine learning with Python. NumPy is used for creating n-dimensional arrays. Here is how we can use the same. So to use NumPy, you have to import NumPy as NP. You can use anything other than NP over here. Now, data science and machine learning is all about taking care of combinations of data. You will have large set of data, preferably numerical data. Okay, so you club those data using NumPy, and those data sets are called arrays. And here is how you create a NumPy array. To create a NumPy array, you call a function in NumPy called array and pass a list over here. And this is how you create a NumPy array. Now, if you know Python programming language, you know that array can be created in Python too. And here is the syntax to create an array in Python programming language. Now, if I go ahead and print both Python array and NumPy array, I don't see any difference over here other than the Python array comes as a comma separated values. Okay, now the very first question that can come on someone's mind is that how is it different from Python list? Because from the example above, it doesn't seem to be having much difference. But why should we learn something called NumPy if we can create the same kind of arrays in Python programming language? Here is how I'll answer these questions. There are two distinct regions because of which we should use NumPy as compared to Python programming language. The number one region is that the NumPy n-dimensional array takes very less amount of memory as compared to Python arrays. Second thing is that NumPy array makes it easy to perform mathematical computations. As you know that machine learning is all about mathematical computations. Okay, now let's first explore NumPy in context of these 2 points. Okay, so I have already created two array called NARR, which is a NumPy array, and PARR, which is a Python array. Let's check the memory usage of Python array. So if I say length of the Python array, it will tell me that length of the Python array is 5. That means there are 5 elements. Now all the 5 elements in this Python array are integer. I want to know that how much memory one integer takes to store. To understand that, what I will do is that I'll import sys. I'll multiply length of Python array, which is 5, into sys.getSize of an integer. I'll get 140, which means that this Python array with 5 elements takes 140 bytes. Now let's check the size of NumPy array. We can call length NumPy array the same way we are calling for Python array, but NumPy array has member variables which we can use. So for example, if we say NumPy array dot size, it will give me the number of elements. It also has a specific member called item size, and if we call that, it will tell me the size of individual items. So it says that size of individual items is 8, which means the overall size is 40. Now 40 as compared to 140 is very less. Consider the machine learning scenario where you are taking lots and lots of data, maybe MBs or GBs of data. The saving is awesome. Not only that, there is no further optimization you can do in Python array, but you can do it in NumPy array. Okay, so while creating NumPy array, you can provide a data type. Now you know that 1, 2, 3, 4, 5 can be accommodated into a single byte integer. We don't need 8-byte integer. So we define a data type called int8, 8-bit integer. And in this case, if I check the overall size of the array, it is just 5 bytes, 5 as compared to 140. That's why I said that NumPy array takes less memory as compared to Python arrays. Okay. Now you will ask a question that, okay, how does it do that? How does the same amount of data being stored in NumPy array takes less memory? Well, there is no magic behind reduced size. Unlike Python list, NumPy arrays are homogeneous in nature, which means that all of the element of a NumPy array will be of same type. For example, let's see this particular Python array which has an integer, floating point as well as a string, and I can just create a Python array with multiple types. You can see that one is integer, two is floating point, hello world is of string type. Now let's come to creating similar kind of array in NumPy array. Now remember what I said, that NumPy arrays are homogeneous in nature, which means that these statement, or if I want to create a NumPy array with these parameter, it should fail. Let's see what happens. You will surprise that it passes. You will say that no, my assessment is wrong. No, that is not the case. What happens that if you provide a NumPy array with multiple data types, it will try to find a data type which can accommodate all of the elements. Okay, so if you go ahead and see NumPy array, you can see that everything is converted into a string. That's not the case with Python array. Okay, and the data type is Unicode 32. This is symbol means stored as little endian. Okay, if you see the data type Unicode 32 bit. So if I multiply Python array first element into 10. Okay, now let's create a simple exercise where I want you to create a NumPy array with a combination of integer and floating point values and check the resultant data type of the NumPy array. So I already have the solution with me, but I'll highly recommend you to just go ahead and do it, pause the video and just do it. So if you do it, you can see that data type is of type float 64, because floating point data type can store integers also, right, as 1.0. Now let's talk about mathematical operations. As I said that there are two regions. One region we have already discussed and seen. The second region is that NumPy arrays are meant for mathematical computation. So let's say if I create the same Python array as well as NumPy array, what will happen if I multiply Python array by 2? You can see that all the elements will be replicated over here. But if I multiply NumPy array by 2, you can see that each element of the NumPy array is actually multiplied by 2. This is a mathematical syntax. If you remember in your mathematics, there is something called vector, row vector or column vector. If you say number 2 before that, it means that everything will be multiplied by 2. Everything in the row or column vector will be multiplied by 2. This is how NumPy array behaves, and this is how the Python array doesn't behave in terms of mathematics. Same is true for two-dimensional array. If I multiply Python array, it will just replicate. If I multiply NumPy array, it will actually multiply the individual two-dimensional arrays into with the number provided. Now this is all about why we should use NumPy. Now there is one special thing I would like to let you know, that how data is represented or used in machine learning most of the time. So in programming, when we create a NumPy array, we are very much used to seeing something like this. Our array means horizontal row of numbers. But in machine learning, most of the time, the numbers are not stored horizontally, they are stored vertically, which means that machine learning takes data input in the form of column vectors, not in the form of row vectors. But NumPy array, it's very easy to create a column vector, which means that we can convert the dimension from a single row to single column, and there is a function called reshape. What I provide in reshape is that, okay, I have 7 elements, I want 7 rows and 1 column. Okay, this is the case. When I give -1, it means that if I provide you one index, one dimension, next dimension you decide. Okay, so if I give 1 over here and -1 over here, the end result will be same. Okay, it says that, okay, I need 1 column, row you decide. So it will multiply and come up with the appropriate dimension. We can check the shape of the NumPy array as 7 row 1 column, and we can check the dimension. It's a 2-dimensional NumPy array. Okay, now I have already talked about row vectors and column vectors. So this is my NumPy array. This is 2-dimensional NumPy array. You can see that shape is 2 by 2 and dimension is 2. So anything beyond 1 dimension, which is called 2-dimension things, are called matrix in terms of data science and machine learning. Okay, now we can create more dimension data. Let me generate a number using NumPy array arrange function. It is very similar to the range function that is there in Python programming language. It says generate a number from 0 to 16 excluding 16, which means that in a step of 1 it will do that. I can say step of 1.5, it will do that. If I say step of 0.5, it will do that. Now I want step of 1. Okay, now I want to reshape this particular generated number into 3-dimension array, which is 4 by 2 by 2. If I do that, I get a 3-dimension array. You can see the shape is 4 by 2 by 2, dimension is 3. Anything beyond 2 dimension is called tensor. Even the row and column vectors are called tensors of rank 1. Matrices are called tensors of rank 2. This is tensor of rank 3. If you have 4 dimension, it will be a tensor of rank 4, and so on and so forth. Okay. Now, since we are looking into NumPy array, let's look into some of the specific utility functions or helper function which will be useful when we are using NumPy. Okay. Now, we have provided data in the NumPy array to generate data, or provided an array in the NumPy array. You can actually generate NumPy array by just calling empty and provide the dimension. It will generate something with a random number. Same thing I can do it for 2-dimension NumPy array. Okay. Now let me give you an exercise. You can pause this video, and what you need to do is that take this particular array, this particular NumPy array, convert this 2D array into 1D array. First exercise. Second exercise is change the dimension from 5 to 25, and here is how your answer should look like. Okay. Now let's see some of the other utility function. If you want a NumPy array with all zeros, you can use zeros function. Okay, you can generate 2-dimension 0, and even you can generate 2-dimension 0 but reshape it on the fly before taking the array. Okay, similar to 0, there is something called NumPy ones, which does the same thing, which generates the dimensioned array with the value 1. You know, these zeros and ones are very helpful when we are talking about a sparse matrix or dense matrix. They are used widely in many of the data structure as well as machine learning algorithms. Okay, let's see one last function called fill. If I want to fill all the elements in the NumPy array with a single value, I can provide that value, and in that case everything will be filled with the number provided in the NumPy array. That's all about basics of NumPy array, which we need to know before we go ahead and start your journey with machine learning. Of course, there are much more functionalities available in NumPy array. I have a separate video series on NumPy. I'll provide the link in the description. I'll highly recommend you to go ahead and look into that. And in next video, we will look into the next prerequisite, the second part of chapter 4, which is matplotlib. That's all for this particular video, guys. Thanks a lot. Thanks for watching. Please take a moment to like, comment, share and subscribe. Thank you. Thanks a lot. And don't forget to see next chapter.